Hello, ladies and gentlemen. We've got ourselves a little forms of line crash course. We've got a test coming up. We're going to see if we can go through everything we have done now all in one place. First thing, you need to know the different forms of line. What can an equation of a line look like? If it says slope-intercept, you need to know, oh, that's y equals mx plus b. And then you need to be able to tell me m, that's the slope, and b, that's the y-intercept. So usually we write that as an ordered pair. It's always going to be 0, comma something. You could say 0, comma b. That would be the y-intercept if you write it as an ordered pair every time. Point slope form. Y minus y1 equals m times x minus x1. Most of the time you're writing an equation of a line, I would suggest you start in point slope form because this is any point on the line as opposed to just the y-intercept. You can start anywhere and m is still the slope. So slope-intercept has a slope and an intercept. Point slope has a point and a slope. They're not fancy names. Standard form is the one we usually use for word problems. That's something like ax plus by equals c. And these don't mean anything by themselves. These aren't intercepts. A, b, and c are not the slope. You can't just eyeball it. You have to then usually we graph using the intercepts, cover-up method if you call it that way. Vertical line, the equation of a vertical line is always going to be x equals something, and the equation of a horizontal line will always be y equals something. So just knowing what kind of line you're working with is going to be really important to get these problems started. So let's talk about just finding the slope. The first thing you got to know is that slope is rise over run, which if you want to think about it as change in y, that's y2 minus y1 over change in x, x2 minus x1. So y2 here is -9, that's the second y coordinate, minus y1 is 6, x2 is 4, minus x1 is -1. So there's one little trick here in the denominator, that's minus a negative. So 4 minus a negative is 4 plus 1, that's going to be 5 down there. -9 minus 6 is -15. So when you simplify that, the slope of the line that passes through those 2 points is -3. If I give you a graph, you can just count it. Count the rise over run. We went down 2, we went over 1, 2, 3. So the slope is -2/3. We read left to right. So always start on the left and then decide if you're going up or down. That determines if it's positive or negative. And then always run to the right. So down 2 over 3 means your slope is -2/3. Graphing lines. So now if I give you each of those forms of a line, you need to know what you're looking at. So this is in point slope. You need to know if it's point slope, they plugged in, remember it's supposed to be a minus sign, so they plugged in a -2. It would have been written like this, x minus -2. That's why we see a plus sign. And it's supposed to be a minus sign, so then that means they plugged in 6. If you look at the equation of point slope, there's usually a minus sign in there. -2/6 is right here. And from there, I can now count the slope, which is -3/4, down 3/4, 1, 2, 3, over 4. So that puts us about here. And I would encourage you to do that several times. The more you do it, the better. Down 3 over 4, which is the same as going up 3, left 4. And then you want to use a straight edge and make it look good. So when I use my tool, I've got that line. So it passes through the point -2, +6, and has a slope -3/4. The second one is in slope-intercept. So you need to know, oh, that's 0, 5 is the y-intercept. So 0, 5 is right there. Then I count the slope, which is -3 over 1. So down 3 over 1, down 3 over 1, down 3 over 1, and then connect the dots, again using a straight edge. Last one is in standard form. So standard form of a line is when you're going to find intercepts. We're going to find the x and y intercepts. And to do that, we're going to plug in 0. So I'm going to have to plug in x is 0, and I'm going to have to plug in y is 0. If I plug in x is 0, then I have this little equation, -3y equals 24. If you divide both sides by -3, you get -8. So when x is 0, y is -8. That's down here. When y is 0, you get this little equation, 4x equals 24. That means x has to be 6. So that's my other equation, or my other order pair, 6, 0. I've got my x-intercept, I've got my y-intercept. All I need are 2 points to make a line, so that's not the best. Let's try That's pretty good. Now, it doesn't tell you the slope, but if you want to find the slope, you could count up 8 over 6. So if you had to rise 8 and run 6, then the slope would be 4/3. 8 over 6 is 4 over 3. Okay? You can just count the slope if you have the picture in front of you. And now I should be able to go up 4. 1, 2, 3, 4 over 3. 1, 2, yep, and I get another ordered pair. Good. So those are just knowing the forms of a line and how to graph them. Horizontal lines, so the way I think about this is if I pick a few different order pairs, let's say this is -8, 5, this is -2, 5, this is 7, 5. So the way you want to remember this is, it does not matter what x is. Does not matter what x is. The only thing that is going to always be true is that y is always 5. So the equation of this line is y equals 5. You're going to go left and right forever, but the equation of the line is y equals 5 because it doesn't matter what x is. The slope of the line is 0, m equals 0. So if you wanted to write it in slope-intercept form, which would be kind of silly, you'd say 0x plus 5. We normally just write it as y equals 5. Graph x equals -3. So again, here, if x is -3, it doesn't matter what y is, and what ends up happening here is you create a vertical line. X is -3 no matter what. Even if y is 8 or y is 6 or y is -8, x is still -3. So that's the equation of a vertical line. And the slope of that is undefined. Because if you count the rise over run, you rise any amount and you run 0, you cannot divide by 0. So if I rise 2 and run 0, you can't divide by 0. It's undefined. The slope is undefined. Parallel and perpendicular lines. Parallel lines have the same slope and they have different y-intercepts. Same slope, different y-intercept. If they have the same slope and the same y-intercept, they'd be the same line. So you have to make sure you say that. Perpendicular lines have opposite reciprocal slopes. Now, it doesn't matter where their y-intercept is because they'll still be perpendicular. They're intersecting at a right angle. Perpendicular lines have opposite reciprocal slopes. So if I say what is perpendicular to this line, well, you first need to realize that is in slope-intercept form. I missed an x in there. mx plus b. And the slope is right there next to x. So the slope of the original line, the slope of this line is 3. The one that I want, the one that's perpendicular, is the opposite reciprocal. So we need to flip it. Instead of 3 over 1, it's going to be 1/3. Instead of positive, now it's negative. So m equals -1/3. Write the slope of the line parallel to this. So again, you need to know this is point slope. Y minus y1 equals m, x minus x1. So then you can be able to tell me, oh, the slope is right there. The slope is 4. So the slope of this line is 4. Well, if you're going parallel to that, then you have the same slope. So the slope that will be parallel is also 4. The slope of the line is 4. They're the same. They're parallel. Equations of lines. So I'm going to pretty much always do these in point slope because I don't need to think about the y-intercept. If you want to convert them, you can. But unless it asks me to, I'm not going to. So it says, what is parallel to this? And passes through that. If it's parallel, then they have the same slope. So the slope I'm going to use is -5. And I'm going to pass through that point. So I have an x1 and a y1. So when I write my equation, y minus y1 is 6 equals m. The slope I'm using is -5. X minus -1 is going to show up as x plus 1. So now we've got the equation in point slope, and we're finished. If you want, you can distribute and find the y-intercept, but I don't, so I'm going to move on. Write the equation that is perpendicular. So again, in point slope, we need to know the slope that is perpendicular is the opposite reciprocal. Find the slope, flip it, change the sign. Now I have a slope and I have a point. So that's actually the y-intercept. You could write it as y equals -3/2 x plus 6. Or if you want to do it in point slope, y minus 6 equals -3/2 x minus 0. Both of these are fine. But since they give you the y-intercept, I know it's the y-intercept because x is 0. You can go straight to slope-intercept as well in this problem. And the last one says write the equation that passes through points. So you need to first find the slope. So I'm going to do y2 minus y1 over x2 minus x1. And I get 7 over 9. because these end up being pluses. So 1 plus 6 is 7, 7 plus 2 is 9. Now I can pick either point. It doesn't matter which one you use. So I'll just use the first one first. Y plus 6 equals 7 over 9, x plus 2. That will be at this point. Or you can do the other point if you want. Y minus 1 equals 7 over 9, x minus 7. Both of these are correct. It just depends which point you pick to pass through. The line will pass through both points, and if you were to distribute, you get the same y-intercept. Last thing is linear regression. So this says Abigail gathered data on schools' winning percentages and their yearly salary of their head coaches for 11 years, and then she created a scatter plot. So you can see the general trend seems to be that as you're moving to the right, as the salary increases, the winning percentage increases according to this trend. Doesn't seem like it's a particularly good fit. But they tell you the slope of the line is 8.42. So the context here is really important. You got to figure out what your units are. We're talking change in y over change in x. So the y units is the winning percentage. The x units is salary. And it's per $1 million. You're always going to divide by 1 unit in the denominator. So it's 8.42 over 1. So what this means is you can say the same thing every time. Your numerator is your first unit. The winning percentage, because that's your y unit. The winning percentage is, since it's positive, increasing by whatever that slope is, 8.42. And since it's a percentage, I'll say 8.42%. For every one of whatever the denominator is. So that would be every $1 million of pay increase. So the general trend here, according to this line of best fit, is that for every $1 million you pay the coach, you will win about 8% more. And if you look at it, like let's just look right here. If you pay $0 million, that doesn't make sense. They would win 40% of the games. $1 million is about there. That looks like it's about 8%, 48%. $2 million from 48 up to, that's probably about 56. Again, 8 up again. If you look here. So we were about 56, that's about 74. You can see how this is rising 8 for every 1 that it runs over. So the slope is 8.42, and it's 8.42% for every $1 million pay increase. So that's if I give you the graph. What if I don't give you the graph, but I give you sort of the data? So you won't have to generate it, but you could type this all into Desmos, and you could generate this, but I did it for you. So if it says, what's the equation of best fit? They're giving you the slope, they're giving you the y-intercept. So y equals negative 0.0064x mx plus b 49.597. So 0.0064x plus 49.547 mx plus b. They give you m, they give you b. What does the slope mean in context of car weight and gas mileage? So again, think of your units. Change in y over change in x. Change in y is mileage, gas mileage, and this is for every 1 pound, for every one of these. So does the gas mileage go up or down? It is negative. So the gas mileage decreases. I'll type this one. The gas mileage. Ooh. Whoa, what's going on? There we go. The gas mileage decreases by whatever the slope is, 0.0064 mpg for every 1, whatever the x units are. It's changing y over changing x. So every 1 pound. Every 1 pound, the car increases. I'll say car's weight. The gas mileage decreases by 0.0064 miles per gallon for every 1 pound the car's weight increases. Something that might be worth doing in this problem would be to move the decimal. If you were to move the decimal over, let's say 3 times, 1, 2, 3, then we could say 6.4 miles per gallon for every, you'd have to move it here as well, for every 1,000 pounds. That might be an easier thing to describe in the context of this problem. So that would be saying that your gas mileage decreases by 6.4 miles per gallon for every 1,000 pounds you add to the car. That seems like a little more reasonable thing we can understand in our head. And then the last thing is this model a good fit? I am asking for a very specific thing here. If you do not mention the R value, then you're not answering the question. That's what we should be looking at right there. That is a measure of how good of a fit the model is to the data. So it's negative 0.88. If you'll remember, a perfect R value is either plus or minus 1. And if it's a minus 1, what that means is every single point here is on the line. That would be R equals negative 1, if every point is perfectly on the line. So what we have is R equals 0.88, 0.89. That means that it's not quite perfect, but you're going to have some points that are not quite on the line. 0.89 is okay, but there's going to be points that aren't fitting the data perfectly well. So is it a good fit? Yeah, it's a good fit. And you should always say, because that R equals, let's say the model is a good fit because the R value, this is what I'm saying, is close to perfect, which is R equals negative 1. So we probably should throw it in there too. R value of negative 0.89 is close to perfect. Okay, so you're comparing it to plus or minus 1. If it's a positive R value, that just means the slope is increasing. So this is negative, that just means it's decreasing. We're losing gas mileage for every pound of weight we add to the car. So we've done all the forms of line. We've done some modeling with them. If you can do the crash course and you can do the study guide, you should be good to go. Go ahead and mash that like and subscribe button, and good luck.